Today, we will be talking about the Aro powder pump model PP20A-ASS-AAA. The PP20A indicates that this is a 2-inch powder pump. The next 3 digits indicate the connection type, wetted parts, and hardware materials, with the last 3 digits indicating the seat, ball, and diaphragm materials. In this case, we have Santoprene balls, diaphragms, and seats. There's also a medical grade option. This pump is primarily designed for reducing manual effort applications. For example, an operator carries a bag to a mixing or blending station where they cut the bag and dump the powder into the container. This creates several issues. 1. Increased risk of back problems. 2. Respiratory and breathing hazards when cutting open sacks of powder. 3. Cutting injuries when opening the bag or dropping the knife into the container. The Aro powder pump is designed to eliminate all those issues by attaching the suction line directly to the powder pump and directly pumping from the tote or bag to get a smooth flow of powder through the pump into the mixing or blending tank. This also eliminates clumping issues by reducing the possibility that a worker will accidentally drop other material into the mix. The Aro powder pump is also portable and does not need to be pre-installed. It can be moved from station to station using a dolly. It can pump various types of powder, ranging anywhere from fused silica, which is extremely light, to materials like calcium carbonate and paint resins. As you can tell, the powder pump looks like a standard diaphragm pump, only modified to incorporate the Aro patented air valve features, which improves air efficiency, reliability, and allows for install-free operation. First off, you'll see there's a pipe plug installed on the outlet manifold. This allows you to attach an additional air supply to help the powder turn the corner to the discharge line and maintain the dispersion and the fluidization of the powder as it goes downstream. The second modification you're going to see is that both fluid caps have been drilled and tapped. This provides air to fluidize the powder within the cap. The third modification we're looking at is the air valve. You basically see 2 lines coming off the air valve. These lines are tied into the 4-way valve and communicate with the air chamber on each side. When one chamber is pressurized, it is getting a signal from the 4-way valve, and as it switches and changes direction, it pressurizes the opposite side of the 4-way valve. We've added some additional components to the pump to make this work. On the front of the pump is the main air supply. This is an Aro H-series valve, which powers the diaphragms and allows them to reciprocate. The second component is the air fluidization circuit. This is made up of a mini regulator and has an adjustable orifice and an alpha 4-way valve on the back side. This pump features 2 separate air supplies, one for the motor and another for air or gas for the powder fluidization circuit. If you happen to be pumping hydroscopic materials, which absorb a lot of water, you don't want to put water in the air or the powder, because it will cause clumping and eventually clog the pump or collect in the downstream side of the line. You can either supply the powder fluidization circuit with compressed air, assuming it's not going to be a problem for the powder, or you can supply an inert gas, like nitrogen, which has almost 0 moisture content and will keep the powder dry. It keeps the suspension in the pump and downstream. This is a patented feature of the Aro powder pump that can significantly reduce the cost of supplying air to the pump, because you can now use standard compressed air to power the pump and an inert gas to handle the fluidization of the powder inside the pump. A patented feature of the Aro powder pump, the powder fluidization circuit, prevents downtime and damage to the pump by fluidizing any leftover powder. If you have been previously pumping powder, the powder that was in the fluid cap being discharged is going to fall to the bottom of the cap. When the pump starts, the diaphragm and diaphragm plate might come against a solid wall of powder that's in the cap. A couple things may happen. The pump will not run at that point, or, if there's enough force, you can actually bend the diaphragm plates or the bolt that's holding the diaphragm onto the connecting rod. There have been instances where 3/4-inch bolts were bent or broken off. When you plug air into the powder fluidization circuit, it's going to feed air into the chamber that was previously pumping powder and fluidize the powder in that cap. This means that when the diaphragm moves into the cap to displace the powder, it won't run into a solid wall of powder. The pump will start and run normally. The powder fluidization circuit consists of a mini regulator, an adjustable orifice, and an alpha 4-way double pilot valve. In addition, the output tubing goes to each individual fluid cap and conveys air to fluidize the powder. In that line, we also have 2 check valves. The check valves prevent any air or powder from coming back through the alpha valve when we exhaust air, and alternately pressurize and exhaust each line. You'll notice on the alpha valve there are 2 ports. These actually connect to the pieces of tubing we had off the major air valve. These are signal ports, so if you want to apply air to one port, it causes the valve to shift in one direction. When a pump shifts, it sends a signal to the other port, exhaust this port, and the valve will shift to the other. So that will alternate one of these lines to be pressurized and one for exhaust. This is an H-series Aro valve. It's a pilot-operated, normally closed 3-way valve. You'll notice on the body itself there are numbers corresponding to each port. Port 1 is always air supply. Port 2 is connected to the pump itself, so when the valve is on, air will flow from port 1 to port 2. And port 3 is exhaust. When this valve is turned off, we're going to exhaust all the air from the motor and the pilot through this port. There's a plastic plug with a small orifice drilled into it. The purpose of this plug is to make sure that debris does not filter back into the valve. On top of the valve, you'll see another port. This is the pilot port. This valve has a small accumulator built into it, so if you meter the air into the valve, there'll be a time delay before the valve turns on, after the air pressure is applied to the port. Normally, we have to reach approximately 30 psi before this valve will begin operating. As this pump operates, it tends to generate a very high potential of static electricity. If not properly grounded, it could discharge, causing severe damage, especially if used in a hazardous environment.